time for 8.5. In 8.4, we multiplied and divided, yeah, that's past tense. Or devode. Devode could be past tense. But no, divided, we multiplied and divided rational expressions. That's fractions with polynomials in them. Now we're going to add and subtract them. Arguably more difficult task. So let's talk about 3/5 plus. Ooh, this is always so much pressure. 5. Sevenths. Okay, so if we want to add these together, we do not just say 3 plus 5 and 5 plus 7. Okay, it's tempting. We just got done multiplying that way, just multiplying straight across. But to add these things, we're trying to say there's 3 of these fifths, right? We know what a fifth looks like. A fifth looks like this. It's just like a piece of a pie. That's a fifth of a pie. This is going to look so perfect. 1, 2, 3, 4, 5. Oh, yeah, those look the same. 1/5. We got 3 of those. And then when you want to put together with those 5 of these sevenths, which is something like 1, 2, 3, 4, 5, 6, 7. That's better. We got 5 of those, right? There, 5. And we're trying to put them together and say that we have like sum of something, right? Like if you have 5 apples and you have 2 apples, altogether you could say you had 7 apples, right? But these aren't apples. Or if these are apples, these are oranges. We can't put them together. We cannot put them together. So how can we put them together? We have to make them the same thing, right? So how do we do that? Well, of course we know. We've done this so many times. We need to find the lowest common denominator, find a number that this goes into and that this goes into. 5 and 7 both go into, and with not much work we'll find that 35 is that thing, right? So we need to multiply the numerator and denominator here by 7, 7 over 7. Multiply this by 5 over 5, and we'll get 7 times 3 is 21 35ths there. And then 5 times 5, we have 25 35ths. Together we have 46 35ths. Okay, and we've done it all correctly. The really big new thing here, there's nothing new except for this, really, in this section, is just the idea of getting a common denominator where polynomials are involved. But if we can factor a polynomial, if we can, simplify, if we can remember that dividing by a fraction is the same as multiplying by the reciprocal, all these things, we can put it all together and we can add and subtract these rational expressions. Okay, so that's all we have to remember. We just need to find the common denominator between the two before we try and add or subtract. If we can remember to do that, we'll be in good shape. Now, actually finding that least common denominator when polynomials are involved is a slightly more difficult process than when you're using numbers, but it's the same process, really. The same process as when we're looking for the common denominator between two numbers. And I'll show you how. Let's start with a simple example. Alright, so we got x plus 2 as a denominator and x minus 3 as a denominator. And if you can just recognize that you cannot start to put these together yet, you will be in good shape. Believe it or not, just recognizing that you're not supposed to go on from here. You cannot just add these together. If you recognize that, that will set you down the right path. So now that we recognize we can't put them together, we ask ourselves, well, how can we? Well, we need to get the same denominator. How do we get the same denominator? By multiplying each of these by something. You're going to multiply this by something, you're going to multiply this by something else, and the result will be the same thing, right? Now, as with any problem where you need to find common denominators, you can always just multiply the two denominators together, right? Think about it. We're going to multiply this by something and this by something and get the same denominator as a result. So if I multiply this by the other denominator and this by the other denominator, look, we've multiplied stuff together, multiplied this denominator by something, this denominator by something, and the result will be the same. X minus 3 times x plus 2, x minus 3 times x plus 2, the same thing. Of course, we're going to need to do the same thing in the numerator, and the same thing up here in this numerator, and we will get x minus 3 over x minus 3 times x plus 2 plus x plus 2 over x minus 3 times x plus 2. And together we'll get x minus 3 plus x plus 2 over the common denominator. Of course, we want to put common or like terms here together, so we got x plus x, that's 2x, and negative 3 plus 2 is negative 1, and now we have our final answer here. Okay, so we could also always just multiply the two denominators together, but why isn't that the rule then? You know, we seem to remember that finding the common denominator for numbers is slightly more complicated than just multiply the two denominators together, right? Because we want the least common denominator, like that, and then trust me, that's what you want to do here. You just want to multiply them together, just like when you multiplied 5 and 7 together. Why did you multiply 5 and 7 together? Because there was nothing smaller that they could both go into, right? But for instance, let's say 1/6 plus, here, let's make this denominator, this is fun, huh? Like 4. Okay? Yeah, this will work really nicely. And let's make this 3/4. So 1/6 plus 3/4, we want to find a common denominator, but we don't want to just do 6 times 4. That's just way too big. That's bigger than we need, because we recognize 6 could go into 12 and 4 could go into 12. So we could just multiply this by 2 over 2 and this by 3 over 3. And then we'll get 2 over 12 plus 9 over 12 for 11 over 12, right? We see that there's some smaller denominator that these could both go into besides just 6 times 4 being 24. That would have been twice as big. We'd have canceling at the end. That would have been a mess. So how do we figure that out? Well, in our heads, without even really realizing it, we do this. We say this is 2 times 3, and this is 2 times 2. Okay. Now think about what we're looking for. Looking for a denominator that 6 goes into and that 4 goes into. What does it mean that it goes into that number? Lots of different definitions, but one definition that really works well for us is that the common denominator, this that we just found, the number 12, will have all the factors of 4 and all the factors of 6. That way you'll find all those factors of each number in this guy here. And that is a definition of it going into, or being this being divisible by 4, right? If 12 has two factors of 2 and a factor of 2 and 3, then you'll be able to find a factor of 4 in there when you multiply those two factors of 2. And quite separately, you'll be able to find a factor of 6 when you multiply a 2 and a 3 together, right? Well, if we do 2 times 3 times 2 times 2, we'll have included an extra factor of 2. We don't need all of that, right? 2 times 3 times 2 times 2. We don't need that much. We don't need that 2. That's what causes us to get 24 instead of 12 when we do 6 times 4. We get an extra factor of 2 that we don't need, because look at this. We can pair things up. 2 times 3 will give us the factor of 6 that we need. That's 6 times 2, right? And then if we do this, I'll do a square grouping here. 2 times 2, that'll give us a factor of 4. 4 times 3. So both 6 and 4 go into 12. Okay, so long explanation to explain what we're going to do with polynomials. So let's use 1 over x squared minus 4 plus 1 over x squared plus 4x plus 4. Okay, we're going to follow right here, right in this region here. We're going to use this exact process to find the common denominator. Right? We just included the absolute bare minimum factors we needed to get all the factors of 6 and all the factors of 4. Okay, without repeating them unnecessarily. First let's factor both of these. This will be x plus 2 times x minus 2. This will be x plus 2 times x plus 2. Right, so we need two factors of x plus 2, and we need a factor of x plus 2 and x minus 2. so that we can find this as a factor and this as a factor, just like we did up here with 6 and 4. So let's say we need a couple of factors of x plus 2, right? Definitely got to have that in our common denominator, because if we don't, we won't have this as a factor, and we need that. We also need a factor of x plus 2 and a factor of x minus 2. Well, from this here, we already have a factor of x plus 2. So all we need to include in addition is this factor of x minus 2, right? Let's see, this right here makes up this guy right here. So that's a factor of this denominator. And over here, let's, I'll just draw little red brackets there too, and blue. This, separately, this x plus 2, x minus 2, that makes up this, or this, so that both of them are factors of this common denominator. Whatever this would be when we multiply it all out would have this is a factor and this is a factor, okay? So there you go. That's all I'm trying to say. Now we have our common denominator, and it's not overkill. Just like 6 times 4 would have been overkill up here. So our common denominator is x plus 2 times x plus 2 times x minus 2. So now we just need to go about making each of these look identical to this. Right? Just like we would have found that this is 12, and then we just need to multiply this by 2 to get 12, and this by 3 to get 12. So we need to multiply this by another factor of x plus 2. Let's pull this color out. We need an x plus 2 factor for this one to look like this, and we need an x minus 2 factor over here so that it will look like this. And we, of course, always need to do the same thing to the numerator. Okay, so now we get x plus 2 plus x minus 2, and it's all going to be over the common denominator, of course. X plus 2 times x plus 2 times x minus 2. And let's just put together any like terms. X plus x is 2x. 2 minus 2 is 0. So we get 2x over x plus 2 times x plus 2 times x minus 2. All right. So the whole process is factor these out. Right. Maybe let's make a little list here. Factor the numerator and denominator. Okay, then we could write down any shared factors. Okay, what that looked like was these shared a factor of x plus 2. Right, we found those pairs, or that pair, and we could say, all right, we wrote down that x plus 2. All right, and now let's just grab the rest of the factors that we need, all the unique factors. Write down all unique factors. Okay, so then we'll write down an x minus 2 and another x plus 2 so that we get two factors of x plus 2 that we need for this polynomial. And that'll be it. That'll be the way that you find your common denominator. Alright, thanks for watching that very long intro video. And we're going to do this again and again. This won't be the only time that we find the common denominator like this, but we'll do more in the sample problems video. Thanks for watching.